Let us discuss about a force. In your early classes, you might have studied about force. We can simply state a push or a pull, which can cause change in a state of motion is called a force. We can talk about change in a state of motion of a body or a system, and state of motion we simply define by velocity. We can simply state it, state of motion of a body is defined by its velocity, and a push or pull which can change the velocity of body, it is called a force. Or you can simply write force can change velocity vector. Here we consider the vector form of velocity because velocity is defined by two parameters. One is its magnitude and other is its direction. So if only magnitude of velocity is changing, then also we can say velocity is changing. If only direction is changing, then also we can say velocity is changing. So force can change either magnitude of velocity or direction of velocity or both. So about force we are going to discuss several different type of forces we are going to study. The very first thing we'll study is about the fundamental categories of forces. So we can simply state all forces of nature are classified in four fundamental categories. Let's discuss these fundamental categories under which all forces are classified. As just now we have seen that all forces of nature can be classified in four fundamental categories. So here we'll discuss about the fundamental forces of nature. These four categories are, the very first one is electromagnetic forces, the second one is gravitational forces, the third one is strong forces, and the fourth is weak forces. Mainly these are termed as strong and weak forces when these were discovered at the range of nuclear separation. These forces are generally found within the nucleus only, and these two forces are also termed as short range forces. And so many of you might have studied earlier about gravitational force and electromagnetic forces. These are long range forces, or we can say when two particles are at a large separation, then also they'll experience electromagnetic and gravitational interactions. But when we talk about the strong and weak forces, these appear only at separation which is less than 10 to the power minus 12 meter. Only at separation less than 10 to the power minus 12 meter these forces appear. Even in some cases they appear at a separation less than 10 to the power minus 15 meter. Generally in case of weak forces the separation has to be further smaller. So these are the two forces which right now we are not going to discuss in detail. These two we are going to study in detail. And first we are going to discuss about the order of these forces. Just by name we cannot analyze how strong a force can be, how weak a force can be. However, soon you will see that out of these four forces, gravitational force is the weakest force. However, we are having a category of weak forces, but still gravitational force is weaker than weak forces. These two are also termed as nuclear range forces, and they generally appear only within the range of nuclei. So mainly in macroscopic world we deal with electromagnetic and gravitational forces. When you study in detail about nuclear physics, you will deal with strong and weak forces. Let's discuss about the range of these forces also, just to get a basic idea about their ranges as well as their strengths. Now let's see the relative strength of fundamental forces of nature. Now, for a given pair of particles at short range, we can talk about the forces. Say first, if we talk about gravitational forces, and say we consider gravitational force as our reference, or this you can consider as of unit magnitude for a given range or for a given separation of two particles. Now in this situation, the second force, which is stronger than gravitational forces, weak forces. But you'll be surprised to see weak forces for the same pair of particles. These are 10 to the power 25 times stronger than gravitational forces. The nearest strength is that of weak forces, which is almost 25 times stronger than the gravitational forces. The third one is electromagnetic forces. If we talk about electromagnetic forces, these are even stronger, and you can say these are approximately 10 to the power 36 times stronger than gravitational forces. And the last one, which is the force having maximum strength, are strong forces. Again, as I have discussed earlier, that strong forces appear only at the nuclear separation or for the particles within the nucleus only. These are approximately 10 to the power 38 times stronger than gravitational forces. So these strengths I have given you just to give you an idea about the basic strength of forces, or you must be aware about how strong a force can be as far as fundamental forces are concerned. So let's discuss few more points related to force and its applications in further topics.